The lights go off. Systems down. Customers are furious. Engineers are scrambling. And leaders demand answers. Does this sound familiar? Outages impact end customer experience and often a financial impact on the business. Repeated and frequent outages can cause to team burnout. But it doesn't have to be this way. With good observability practices and resilient architectures, you can build architectures which can thrive under pressure. My name is Nisha, and today, with my colleague Paul, you will learn how you can transform monitoring into meaningful insights and empower your teams to go from reactive to proactive. We are excited to be joined by Andrew, who will share how justatakeaway.com have implemented these practices in real world. Let's get started. So I'm going to cover how you can diagnose an issue quickly, and my colleague Paul will then walk you through how you can uncover hidden issues and prevent future ones from happening. So consider an e-commerce website where you have different widgets where customers can browse for products, search for products, and place orders. And in a worst case scenario, your customer service team are getting complaints that they cannot place orders. So a good observability starting point would be have a time series metric where you're measuring the number of times the page has been unsuccessful throughout the journey. But if you see carefully, there is a slight pattern emerging here where there is a problem, and although you have an alarm threshold defined, it doesn't trigger. It doesn't alert you that there's a problem. So what observability technique can you use here to detect the problem and then triangulate it? So I'm going to introduce you to dimensionality in observability. So what is dimensionality? It's when you measure a metric per dimension. So you measure latency, request, errors per website. In our case, per web page. So let's try and understand how does it transform our observability technique. So when you measure request and errors, in the graph that we saw before, we had an overall error rate across overall dimensions. And when you split them into product errors and cart errors, these two graphs give us clear indication that the issue is with the cart. And when you plot these graphs on the same axis, you get a clear signal. And with the right alarms, you have them triggering when the issue has occurred. So we saw here how you can have alarms for cart. But what if there's a site-wide issue, right? You need individual alarms for each use case that matters to your business, to matters to your customers, and you want to track them individually. But if there's a site-wide problem, you don't want your pager ringing a gazillion times, right? So for that, you can use CloudWatch Composite alarms, where you roll up all these alarms into one single alarm. So it only rings once, and you reduce some alarm fatigue. Now you'd wonder, for 5 alarms, why would I go an extra mile to implement this CloudWatch Composite alarm? But the key here is, we want you to measure every single dimension which can fail separately. So you measure the latency, the errors, the volume rates for each use case individually. So throughout this talk, we'll have a key takeaway slide after each section. So the first key takeaway here is use dimensions. Use them to measure the use cases separately, split them into key metrics, and then combine all the alarms together to reduce the noise fatigue. So now that we have diagnosed there's an issue on our website, let's try and understand what is happening. Why is this issue happening? So the 4 failure modes we're going to cover today are bad dependency, bad component, bad deployment, and traffic spike. Let's dig deeper on the first failure mode. So again, I'm considering the same e-commerce website. This is how the architecture is going to look like under the hood, where now that we have a problem with the ordering service, I'm going to zoom in the ordering service workflow, where you have users requests coming in to the web server cart, and then you have the cart server stack. And under the hood, you have EC2 instances in different availability zones where requests are coming in to the load balancers in the web service stack, which passes it on to the cart service stack. Now, how do I understand that there's a problem with one of the requests? So the technique that we can use here is tracing. So tracing is when you stamp the incoming request at the front door. In here is the load balancer with the stamp ID. The trace ID is a unique stamp which follows the request throughout the platform from start to end. So when it stops, you understand where exactly is the problem, and that's where your team needs to start investigating first. And then you can collect all these trace segments for services using AWS X-Ray, which will help you build a service map. So you can get the whole system by aggregating the service segment, the trace segments, and you have a live service map which indicates where the problem is with the red, green, and yellow signal. Now, here's a screenshot of service lens map using AWS X-Ray, and I can understand if it's a bit overwhelming because it's a fairly complex system using different microservices. But if you focus on the two red arrows, the red on those two components indicate where the issue is, and that's where you need to dig deeper. So the key takeaway for bad dependencies: use tracing. Tracing enables you to track the request. It's like a baton in a relay race, which is passed from each incoming call to the outbounding call throughout the platform. And then use these trace segments to collect into a little, using AWS X-Ray, which enable you to actually build a service map. And then use the service map to identify where the problem is and where should the team focus. Next, let's dig deeper into see why is the problem happening, and that could be because of a bad component. Again, the same architecture, slightly rotated horizontally, where you have a web server layer, request coming in from the users to the load balancer, passing it on to one of the web servers, and then what if there's a problem with one of the web servers? If you have correct health checks implemented on your load balancer, right, it will detect there's a problem with one of the web servers, and it will redistribute the request to other working hosts. To the end user, it would just look like a blip. That's fine. They refresh, and everything is backing up. But what if one of the processes on the web server has crashed? Suppose HTTP deadlock. It can talk to some services, but not to everything. So health check would be tricky to identify here. So which observability tool can you use? Yep, dimensionality again. And when you measure errors per instance ID here, which is a hardware component that can fail separately, you get a clear graph. And if you see the instance in pink is that's gone wrong, and when right alarm signals, teams are notified. Yep, and then you can action the remediation here. Now let's see a similar issue, but a different challenge, where again, requests are coming to the web servers, which are then passing the request to a cache node, and each availability zone has its own respective cache nodes for reduced latency. What if there's a problem with one of the cache nodes? This is going to impact more than one EC2 instance, the whole fleet in that availability zone. And it would look like a multi-host failure. Now, how you can identify what exactly is this multi-host failure? Any guesses? Yep, dimensionality again, where you measure errors per availability zone, because again, it's a different component which can fail separately. And once you have identified there's a problem with the availability zone, you can use Route 53 application recovery controller to isolate that availability zone and use the others to render the request for the end user. So the key takeaway here, again, is to implement the metrics for each component which will fail separately. So the mantra really is measure everything that will fail separately. And then you can use metrics inside query to find the poorest performing infrastructure in there and then implement the metric for that dimension. Now let's dig deeper and see if there's a bad deployment. Now, a good practice when you have new code to be deployed in the architecture is when you do a blue-green deployment. You deploy in part of your website, and then once it's successful, you apply it to the entire application. And when you're tracking the metrics and you identify there's a problem with one of the deployment, the error rate's creeping up, teams are paged at 3 a.m. in the morning, they start investigating what the problem is, and they realize there's a deployment, and they decide to start rolling back. And everything is happy again when everything is rolled back. But if you see carefully, The whole duration can be broken down into two phases: the time to detect, which is the time taken by the team to identify there's a problem, and time to mitigate, which is the time taken to fix the problem. And your customer experience has been impacted for the entire duration, and your business is impacted too. So what resilient practice can you implement here to shrink this entire downtime? Automatic rollbacks. Let the computer do the rollback. You don't need a human intervention to decide and take the judgment call if you should roll back, right? So alarms triggered, auto rollback kicks in, which shrinks the time to mitigate way down and enhances your customer experience. So you can implement resilient practices, but if you don't operate them with resilient operation practices, your customers won't see that benefit, right? And when using cloud formation, you can tell your stack which alarm should it monitor, and when it triggers, it starts rolling back. Simple as that. Let me focus now on time to detect and understand how we can detect the problem quick enough. Any guesses? Yep, dimensionality again, where we measure the number of errors per code revision. And when you track the error rate for code revision, you can see there's a significant spike when the new code is deployed. And that's a clear indication that that's where the problem lies. And when it's detected quickly, and auto rollback also kicks in, the time to detect and time to mitigate shrinks way down. And that's as better as it can get, apart from not deploying a buggy code at the first place. And then you can implement cloud composite rollback alarm so the teams are aware that the code that was deployed had errors, and you can use CloudWatch composite alarm again to roll it back into one overall alarm. So the key takeaways here, again, use dimensions to detect a logical boundary, in this case, deployment ID, because it can fail separately, it can impact your business as well. And we care about all these use cases. And roll back automatically. Don't rely on a human to actually make that judgment call when actually things are burning. And combine all your alarms to reduce the noise fatigue as well on your teams. Traffic spike. Traffic spike can sometimes be a success as well when you have many customers accessing your application, but sometimes it can also cause latencies. So you might resonate with this workflow where you have an alarm triggering that the customers are experiencing latency on a website. You start investigating with your service map, identify the component that is a problem, and then you see a spike in the latency as well. You then try and check if there was a deployment that has happened recently. No deployment, okay, what next? You try and check the fleet metrics. You see a spike in the fleet CPU, and then you see the fleet size increasing. So auto-scaling is kicking in, more hosts are being deployed. And you see the spike which resonates with the latency, define a go, where there's a huge spike in the request volume. The key here is to understand what exactly is causing this request spike and where are these requests coming from. So what tool can we use here? Okay, I think you must have guessed it now. Dimensionality again, where we measure errors per request ID, per source where the request is coming from, could be a client IP address or anything which is unique. However, if you look at the attributes in the table, they are in a certain order where you have few websites, few availability zones, but many customer ID. Could be 500 or thousands or millions. And that's where cardinality can help. Cardinality helps us when you're trying to track the errors per request ID. And if you try and measure that graph, it's practically impossible. You do not have enough pixels to plot a graph like this. But you focus just on top-end requests, so like top 500, for example, you can get a clear indication, actually, where is the request coming from, and then you can use log insights queries to dig deeper on these metrics. So the key takeaway on how to identify traffic spike, use CloudWatch contributor insights, which will give you the data from high cardinality, and just focus on the requests that really matter, right? And that will give you the information exactly what's causing the spike. And lastly, use log insights queries to split and analyze these metrics, and which will help you give you more indication to find the cause. I'm now going to hand over to Paul, who will cover the next topic.
Thank you, Nisha. So we're going to talk through how you kind of uncover hidden issues. And part of that is looking at it in two types of ways. There's external issues, and then there's these misattributed faults. And I'm just going to walk through what that might mean for you. So an external issue, everybody's familiar with, you monitor your website, you monitor the components within it, you've got all of your detailed observability in place, but actually, do you know what your customer or your user experience is like? In that scenario, how do you look at the outside world view, the actual real user experience of engaging with the application stack? So I've got a scenario here where you have pushed a piece of code out, you are delivering it across two pieces of technology. So your core application is on your EC2 instances, and you're pushing it out through a content delivery network, CloudFront, for AWS users. And what you're doing is saying to the user, off you go, start engaging with the application. It gets the initial kind of update from CloudFront, and then starts to interact with the back end. Then you decide we need to add some features, new capabilities, whatever. Version 2 gets pushed out, but something doesn't quite work the way you expected it to, because version 2's only made it as far as the CloudFront distribution and not made it into your EC2 instances. So the scenario you end up with is you've got your nice shiny new version of the code, your users have gone out to the CloudFront and got the latest updates, started to send the queries back to the back end, and the back end goes, I don't know what you're talking about. I've never seen this code before. So how do you collect metrics and data on that kind of experience? So for me, CloudWatch Real User Monitoring is the way to do this. It's a really good way of getting insights as to what your users are doing. It's also very, very low friction. And what it'll do is it will take the data from your user experience and put it into CloudWatch for you. And on the back of that, you'll then be in a position to be able to get the data back, see where the errors lie, see where the problems are, and be able to zone in very, very quickly. So you then kind of evolve the application stack, and you say, right, how do I make myself more cost optimized, more scalable? I'm going to refactor from EC2 into containers. My containerized workload is ready to go. We've done all of our testing. We think everything's fine. But you've got a situation where you're going to use something like Route 53, our global DNS service, and you're going to do weighted deployment. So you say, well, maybe just 1% will get moved over to the new platform whilst we test it, and you move them over, and all of a sudden your real user monitoring is coming through, and you're starting to see every single one of those is errored. And it's because somebody's pushed a network access control list or a security group from a pre-production environment into your production environment, and you didn't catch it early enough. So how we would typically deal with that kind of scenario? Well, CloudWatch Synthetics is a great way of doing that continuous integration testing in the background. You can do it before you get that external user case. You can also make sure it's sat there saying, is this part of the site still working? We've just done a deployment. Does everything still look the way it should do? And in conjunction with the real user monitoring and this, you get to have that confidence to say, yes, we can switch over and get things moving. So look at issues like a real user, a real client. Make sure that you're working backwards all the way from the end user experience, so you can see all the way through the broader estate. And make sure that you're doing that unit testing at all times as you go. Misattributed faults are an odd one. I've spent many, many hours, usually in the middle of the night, trying to figure out where the problem lies. And a good one has always been, you've got server faults in the HTTP stack, and you've got client faults. So you've got that 400 messages coming through, or the 500 messages. And typically what you will do is you'll see an error rate kicking in. These are my 400s. Look, I've got a blip. I wonder what's driving that. So as Nisha talked about, using that dimensionality piece, you can break it up and say, well, oh, I can see what's caused that spike. It's the user, what was it, ABC123 or customer 123? They are the one that have driven the spike here. I've got nothing to worry about. There's something wrong on their end. What happens when you see something like this? You're in a scenario where all of your users, all of your customers are sat there driving 400 errors into your logs. That doesn't feel like it is actually an issue on the client side. So how do you diagnose that? And that really comes down to the data that you're working with. So far you've been tracking the percentage of requests with errors, and actually what you want to do is say, well, where's the business value in this? And the business value here is how many of our clients are actually erroring. So if it's one or two, you've got the dimensions that be able to give you the insights of who they are and those high cardinality figures. But then you've also got the position to be able to say, actually, all of our clients are alerting at the same time. There's something wrong with the last deployment, or there's been a config change that has affected the overall estate. So for the misattributed issues, it's all about making sure that you're working backwards from your client data, making sure that you're using business as well as technical metrics to be able to support your outcomes. And an example of that is percentage of customers versus the percentage of requests, because that's what's really driving the technology side of things. I'm going to hand over to Andrew now from JustEatTakeaway.com. He's going to walk you through his kind of lived experience of implementing observability this way. Andrew.
Thank you, Paul. So in this talk, I'm going to give you some insights into how we instrument our services, how we respond to failure, and the operational best practices we follow. But first, I'd like to take the opportunity to give a massive thank you to our engineering community at JustEatTakeaway.com, who are responsible for many of the principles and practices that I'll discuss today. Before we dive in, I'll set the context. JustEatTakeaway.com operates at a global scale. In 2023, we worked with 699,000 partners, 84 million active customers used our platform, and we fulfilled 891 million orders. All of this is supported by a platform which is formed of hundreds of microservices which integrate with many AWS and other third-party services. So how do we ensure that we have the right level of instrumentation, the right level of telemetry data to successfully and confidently operate our platform? How do we ensure that our customers and partners are always delighted? To answer that question, I'm going to take a step back and look at how our platform is built, how we add the right level of instrumentation to give us the insights that we need. At the foundation of this, our culture is a culture of trust and ownership. Our engineers not only build our platform, but they are on call and operationally responsible for their services. As we have seen, we can identify and respond to issues when we have the right signals. But for this, our services must be instrumented. We actively encourage our engineering teams to instrument their services to give them the insights they need to have confidence that their services are operating well. Metrics give us real-time insight into the behavior of our services. They're the backbone of our monitoring and alerting systems, and they allow us to react to events and predictions as they occur. They're also really useful when viewing behaviors over time, and we might be able to spot regressions in behavior between different versions as they're deployed. As Nisha mentioned, high cardinality often gives us much more insight into issues, but we need to weigh this against the capabilities of our tools and ensure that we have the right types of data going to the right systems. Generally, we'll recommend that our engineering teams use logs or traces for high cardinality data. Logs give us great insight into issues. They add context, color, and detail about the requests and events that flow through our systems. Essentially, they tell a story about what's happening. They're perfect for high cardinality data, and combined with structured logging, we can make data available in a format which is easy for our engineers to query and analyze. Many of you might be aware that logs can be a bit noisy, so we regularly ask our engineers to review their logs and make sure that they're sending us interesting, unusual, or noteworthy data, and just reducing the noise to make it easier to search through logs in the future. Traces give us the detail between and within our service boundaries. They're fantastic for giving us the bigger picture, which is particularly useful in large distributed systems where the connections between our services might be otherwise hard to visualize. They allow us to identify issues like bottlenecks or performance issues. But again, as with logs, we tend to recommend that we use sampling to just keep the noise levels down so that we don't store all of the data. It just makes investigating an issue in the future a bit easier when there's less noise to search through. Generally, we'll recommend for our engineering teams to use auto-instrumentation, as it really helps to give them a head start when adding instrumentation to their code. But we also ask our engineers to remember to add custom instrumentation, particularly for requests and flows where they want that little bit of extra detail. So as monitoring and observability tools have evolved over time, they've become really feature-rich, and in reality, the lines are really blurred between metrics, logs, and traces. And we use this data in conjunction with one another. We might infer metrics from logs or traces to raise awareness about a new issue, or link traces to metrics or logs to see the wider picture at a point in time. This ability to seamlessly switch context between metrics, logs, and traces really empowers our engineers to quickly and efficiently identify issues. So looking at our engineering practices, we have a really large and diverse engineering organization at justeattakeaway.com. We've taken the time to listen to our engineers, to understand their pain points, what they like and what they dislike, and what they would like to see in the future from their observability tooling. With this insight, we've built an observability North Star, which defines a consistent, long-term vision for the tools we will use and the principles and practices that we will follow. By following this vision, we expect that we will reduce cognitive load for engineers, allowing them to move more quickly and react more effectively to issues as they happen. On this theme of moving towards consistency, we want to take our existing tooling and the existing ways that we instrument our services and consolidate them over time. At the moment, like many of you here, we're using tools like Graphite, StatsD, Prometheus, a number of different logging libraries, a number of different tracing libraries. But OpenTelemetry has arrived on the scene in recent years as a vendor and tool-agnostic, consistent way to produce telemetry data. And we really think that it will help us to become more consistent in the way that we produce telemetry data over time. In the short term, this will allow our engineers to instrument their applications in a single way. And longer term, it will allow us to be more flexible about where we send our telemetry data, as it's in one format that we can send to a backend that we choose. Following on from this theme of consistency, we also want to be consistent about the attributes that we have on our telemetry data. So this might be tags or labels. So on this theme, we're kind of looking to have consistency about environment, team, version, and service. So for the environment, that's like deploying to production. For service, that's the name of the component that's deployed. For team, that's obviously who has built and is owning that service. And version is just the code revision, as Nisha mentioned. We release our software hundreds of times per week, and this ability to compare versions across deployments is particularly useful for identifying issues and knowing when to roll back if an issue occurs. And longer term, our aim is to kind of take these best practices that Nisha mentioned and start rolling back when we spot regressions. So I've spoken a lot about instrumentation, but I'm not here to say that the space is solved for us. Our platform continues to evolve and grow, and we do still have the occasional issue. But the key here is that we learn from those issues, and we continually try to improve our response. Fundamentally, we want our engineers to be empowered to spot issues and respond to them, so we don't want any blame culture, and there are no repercussions when an issue occurs. Instead, we take the opportunity to learn from issues, and then use that learning to prevent future issues happening. This information we share with our whole engineering organization at regular intervals, and teams will then take that information and analyze it internally. So I just want to take a moment to talk about graph clubs, which are something that we do at justeattakeaway.com, where they're kind of a regular scheduled meeting where teams will look at their telemetry data and try to proactively spot or identify issues before they become a problem. Essentially, we're also striving for happy and healthy teams, and part of that is for our on-call teams. We want them to be responding to actionable alerts and to avoid alert fatigue due to noise. Graph clubs present an opportunity for teams to review their telemetry data, review their alerts, but they're also a chance for them to kind of get together and look at the data and say, that just looks a little bit odd, and to dive into the detail of something that might become an issue in the future. Well, you may be asking as well, with all of the machine learning and AI that's available, why are we still doing manual checks like this? Well, indeed, machine learning tools will offer insight into things that might be a problem, and we feed this data into our graph clubs, but AI is not yet writing our services and operating them. So graph clubs offer an opportunity for teams to share knowledge internally and gain insights into how their services are behaving. They can also be used to validate key performance indicators to ensure that they're meeting the expectations of the team and their stakeholders. So we have a well-established monitoring and observability practice at justeattakeaway.com. Service level indicators, objectives, and agreements are also well established in our industry, but due to the lack of consistent tooling, which I mentioned earlier, we found them a bit tricky to implement in practice, and this is where our North Star comes back in again. We'll use our North Star to define the consistent tooling that we will use, and we will unlock SLIs, SLOs, and SLAs. With our engineering teams, we're aiming to focus more on the outcomes of their services rather than those services being technically operational. With this approach with SLIs, SLOs, and SLAs, we believe our teams will gain greater insight and be able to make more intelligent prioritization decisions about where to focus reliability and resiliency efforts. So the resiliency of our platform is really important, and we will always prefer to be proactive rather than reactive. Our services are well instrumented, but we can still do more to validate our assumptions and improve our confidence levels. And this is where load testing comes in. We regularly and routinely load test our platform, both at the service level and at the platform level, to ensure that that platform is operating as we expect. At the service level, our teams can gain insights into where their services might be saturated or where high load becomes a problem. At the platform level, it allows us to validate that our end-to-end flows are operating as we expect and to spot any bottlenecks or issues which might be occurring with those deployed services. So we've got a well-established load testing practice, but again, on the theme of engineering excellence, we're always looking for new opportunities to improve resiliency. Chaos engineering and chaos experiments have come onto the scene in recent years as a way to kind of test your infrastructure against various failure modes. And you can gain some really valuable insights about how your software will respond to failure. One of the most interesting use cases for us is to perhaps reproduce a previous failure and validate that the mitigations that we've put in place are working as we expect. Really, we're just scratching the surface of what we can do with chaos engineering, but we're really confident that it will be a key part of our reliability and resiliency efforts in the future. I'm now going to hand back to Paul, who will talk about preventing future issues. Thank you very much.
Thank you, Andrew. So I'm going to talk a little bit about some of the stuff that Andrew covered there, and that's preventing the future issues type scenarios. Once again, broken this into two scenarios. One is monitoring your utilization, and I'm going to steal some of the stuff from Nisha's portion. And the other is running game days, so simulations of your broader environment. So what do we mean by monitoring utilization? Typically, this is going to be the kind of things that you come to the cloud for, the elasticity, the scaling up, the scaling back down again, and how you go about doing that with your EC2 deployments, with your load balancing, and also ultimately through auto-scaling groups. So with an auto-scaling group, you're typically going to put in a whole bunch of utilization metrics that are your thresholds. You're going to say, once the CPU hits this level, or once the memory hits this level, you're going to be able to then take an action that says, I can scale out my broader estate. You'll get an alarm that triggers to say, this is going to happen. Dashboards will flag that it's going on, and the auto-scaling group will do its thing. It will bring up more instances to support your workloads. A really good starting point for this, and most people don't think of auto-scaling groups as a form of observability, but it's the way of thinking in terms of, well, how does this grow? And it is by collecting those metrics and taking actions on the back of it. And if you're going to start with, say, the architecture Nisha was talking about, you've got your 9 instances across 3 availability zones. You set your thresholds across those 9 instances to grow, but your auto-scaling group is kind of defined at that. You come along, you say, well, I need to make it 18 or 100 or 1,000. Well, when I'm in that position, it becomes a lot more complicated to be able to manage those kind of numbers. So the focus should really be about defining, percentages. As my auto-scaling group grows, think of it in terms of the percentages that I need to make it grow by. And that's where I set my thresholds, so that I'm responding to the events as my estate grows, as my business grows, and as my customer base grows. But you need to think about it across different abstractions. And those different abstractions mean that, yes, with EC2, you're looking at the CPU, the memory, all of those kind of things. When you're doing RDS, yeah, similarly, you want to do CPU and memory. You might want to throw in there some IO weight stuff, or track your IOPS to ensure you've got enough throughput. But then you've got something like Lambda, and with Lambda, you're going to be in a position where you say, well, actually, it's concurrency that matters to me here, or staying on top of quotas. So being able to understand the dimension or the attribution of the service that you're using and respond accordingly to that is really, really critical. Now, to help with that, out of the box with CloudWatch, you get the capability of having automatic usage metrics that you can dashboard. At the start of this month, that capability landed in the console app for mobile phones. So if you define these dashboards, you can fire it up on your phone, have a look at the dashboard that really matters to the service that you care about. But you come to the cloud for that scaling and capabilities, but make sure you've got that auto scaling so you can scale up, but also scale back down again and have the threshold set accordingly. And just measure the utilization of everything. Now, this is my favorite part of this talk. I love talking about game days or simulating the workloads. And Andrew talked about it in terms of the chaos engineering that they're introducing into justeattakeaway.com. And when I think about these things, it's about what is it that we're looking to achieve. It's not just enough to do a game day for the sake of practicing a particular scenario. What you really want to do is make your environment as production-like as possible, so that you can say, when I'm simulating this workload, I have all of the capabilities that I would see in my production environment, and I know what it looks like, and everybody's prepared and organized in a way that can respond to it. You're using the same playbooks and runbooks for your simulated environment for the game day. And then you can use technologies like Fizz, so the fault injection service. And what this allows you to do is it injects a little bit of entropy into that environment. And on the back of that, you can then start to take data out and really build on those learnings. So the key bits to this is that you need to replicate your production environment, that you need to verify the behavior and make sure that you are collecting all of the stuff using all of the tools that you do in your production environment, so you have a real muscle memory kind of response to your broader environments. And then you take all the data that you get of that, learn about that, and then feed that back into your production environment. So one of the things I like to think of in terms of this is, any golf fans here? Show of hands if you're a golfer. I'm not in any way. My midlife crisis is a bicycle with pedals, so I'm not gone anywhere near that side of things. But there's one aspect to golf. In the 60s, there was a famous golfer who he used to, like they all do, go around the course before a big tournament. He'd find himself in a bunker, and he'd chip out the bunker into the green, and chip and chip and practice and practice and practice until he could get a hole in one straight out of the bunker. And one day somebody came up to him and said, "You're the luckiest golfer I've ever seen. 5 hole-in-ones in a row there. That's amazing." And he said, it's funny, the more I practice, the luckier I get. And that's the way I view kind of game day type stuff or simulations. It's you practice to build your own luck. You need to be able to set up something that allows you to flex that muscle memory and build going forward, and take the things that you learn from those environments, from those simulations, and feed it back into your production environment to the point where you can get where Andrew was talking about in terms of injecting a little bit of that entropy and chaos into your production environments, so you're able to test in a more robust way as well. But the key for me is do this regularly, do it frequently. Practice, 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 create your own luck. And use the same tools regardless of the environment, because if you're not simulating your actual production workloads, then you're not going to get the benefits out of it that you want to get. Now, for the next steps, always say have an observability strategy. What does an observability strategy mean? It goes back to Andrew's comments about the North Star. What is it that you're looking to achieve for your business? And how do I build the thing that's going to allow me to achieve my business goals? Think about dimensions, as Nisha was talking about, and run simulations. Get that muscle memory going. Make sure it becomes part of your culture in terms of the folks that you're dealing with on a day-to-day basis. So when something goes wrong, people know how to respond. They know where to go. You're saving that valuable time. And celebrate success. That's always a big one. We always forget to do that. Now, as a part of this, there's some really, really useful builder's library material. You can go off, experiment with this stuff. It talks through some of the scenarios that have been here. There's a lot more material available in the builder's library than this, but these are the ones I want to call out about the observability side of things. If you want to stay in touch with any of us, these are our LinkedIn profiles for the QR codes. So if you want to reach out, any follow-up questions or likes, feel free to ping us on LinkedIn. And last but by no means least is the survey. Please, we only make these things better by learning from the folk in the room. So if you've got any feedback, let us know. We're going to be around for the next 5 or 10 minutes. If you've got any questions, feel free to come up and talk. And thank you very much for your time today. I really appreciate it.